Okay, so on these, if you were to graph it, right, just do a little rough sketch. So the denominator, you would set that equal to 0 and solve, and you'd get x equals 6. And so that's where the vertical asymptote occurs. Now, you don't really have to graph this to answer it, but I'm just trying to give you a little bit more detail on what's going on here. And then if you take the numerator and set that equal to 0, you're going to get x equals -3. And what that technically is the x-intercept. And so if you were to plug in -3 for this, you would get 0 over -9, which would be 0, right? So you have an x-intercept right here at 3, right? And by the way, the horizontal asymptote is at y equals 1. So you've got that kind of going across right here. And so I don't know exactly what it looks like, but it's probably something like something up here and then something down here. And so see what happens at the asymptote right there at x equals 6, there's a sign change, right? Y goes from being negative to being positive. Now that doesn't always occur, but it typically occurs, but not always. And then at an x-intercept, which that's what this is, that's the x-intercept, there's going to be a sign change there unless it were to like bounce off or something like that. But you're not going to see that with these types of graphs. They're going to cut through it. So once again, you see a sign change in the y value. The y value goes from being positive to being negative, right? So back to our question right here. This expression, they want to know when is it greater than or equal to 0. So what you want to do is find those two key points. And sometimes x-intercept can be included and sometimes not. It depends on the inequality sign. Since you have the equals to part, this will come out as true, okay? So if you were to plug in -3, what would happen is you would get 0 is greater than or equal to 0, which is true. So that means that that means that -3 is definitely one of our solutions. But then what we want to do, if I were to draw a number line right here, so, and this is the way I probably did it in the video, the original lecture video. You put 6 here, you put -3 here. Those are your key points. And like I said, we know that -3 is included because if you were to plug it in, it would give us a true statement, right? If you were to plug it in, it would be true. If you were to plug in 6, you would get undefined because you can't divide by 0. So that one can't be included. So I'm just going to put an open circle there to indicate that. And then what you're supposed to do is you're supposed to test values in each of these sub-intervals right here. There's 3 sub-intervals. So like right here, I could test x equals -4, and we could see what happens. If I plug in -4, I'll get -1 divided by -10. Is that greater than or equal to 0? Well, that double negative will turn that positive. And so I have a positive number greater than or equal to 0, which is true. That is true. Positive numbers are greater than 0, right? So this part of it would be true right here. And that's what you had written right here when you're kind of asking that this was what they gave you. So that's that first part. Then you could test something here. 0 is always a good one to test if it's available. So if you were to plug in 0, you'll get 3 divided by -6 is greater than or equal to 0. Well, you have a negative ratio right there. So this one's going to be false. So that means that that subsection does not work. So you don't want to shade that. Then you need to pick something over here. You can pick 7, 8, 9, whatever you want to pick. Just pick 7. So if you plug in 7, you're going to get 10 over 1 is greater than or equal to 0. Once again, that will come back as true. So you can shade that part right there. And you'll notice that we have the open circle on 6. And so that's why I have a parentheses at 6 right there. So from 6 to infinity. And then over here, it was from -infinity to -3. And you can kind of see that, yeah, that's what I have in my picture right here. Because instead of having 0 right here, you're trying to figure out when is it greater than or equal to 0. Well, in this case, y is kind of taking the place of 0. And so it is greater than or equal to 0. The y value's here and all of this part right here. All right, hope that helps.